Okay, now, covariance of two random variables, x and y. Notation used, covariance of x and y. Covariance is used to describe the strength and the direction of linear association between two quantitative variables, okay? Between two quantitative random variables. And the definition of covariance xy is defined to be the expected value of x minus ex and times y minus what? Ey. Okay? That's how we define covariance of xy. And the shortcut formula. The shortcut formula for covariance xy is E xy subtract by ex times ey. Okay, let's give a very simple proof, okay, to show why they are equal. Covariance xy defined to be the expected value of x minus ex times y minus ey. Okay, then let's expand it. X times y, and then subtract by x times ey. And then minus ex times y. And minus ex times minus ey. Minus minus give you a positive term, ex times ey, okay? Now, recall the property of expected value. The property of expected value. Property 1. Expected value of a constant is a constant itself. Second one, expected value of the constant times a random variable x. This gives what? The constant times expected value of the random variable. And the third, expected value of x plus y is ex plus ey. Okay? In this expression, c is what? C is a constant. Okay? So, x is a random variable, y is a random variable. So x times y is still a random variable. We can apply what? We can apply the property 3 of expected value. Property 3. This one, I can tear this 4 term into 4 parts. First one, expected value of xy. Second one, expected value of x times ey. And next one, minus expected value of ex times y. And the last term, expected value of ex times ey. Okay? Now, if we want to go further, okay? This one, of course, very simple. It's just expected value of x, y. But next term, tell me, ey is a random variable or ey is a constant? Think about it. Give you 5 seconds to think about it, okay? X, of course, is a random variable, but what's ey? Is ey is a random variable or ey is a constant? Of course, what's ey? the center of y distribution, and you have only one center. So EY just a number. So we treat it as what? As a constant, C. So this is a constant C. Expected value of x times the constant C, you can pull C that's the constant out. So I can rewrite this expression as EY, because I pull this term out, right? EY times expected value of x. Similarly, this one can be rewrite as EX times what? Times EY. Now, look at the very last term. EX is a constant, EY is another constant. So the multiplication of two constants still just a number, right? So look at the property one. Expected value of a constant is a constant itself. So this one I can remove what? The expected operator outside. So this one can be written as EX times EY. And cancellation of EX times EY. So what do we have? We have expected value of XY minus EX times EY. This is what we call the shortcut formula. Okay, this is what we call the shortcut formula. Okay, let's take a while. Think about this. Let's take a short break of 10 seconds before I flip to the next page. Okay. Based on what I just covered, okay? Based on what I just covered, let's look at more property, okay? Covariance of xy is defined to be the expected value of x minus ex times y minus ey, okay? And the shortcut formula gives exy minus what? Ex times ey. Next one, we're going to talk about properties of covariance xy. Property one. Property one, okay? Covariance xy is equal to covariance yx. Order doesn't matter. The linear relationship between x and y is the same as the linear association between what? Y and x. Okay? You change what? Whenever you see x, you replace by y. Whenever you see y, you replace by x. You're going to get what? Get the same thing, because multiplication is commutative. Okay? Order doesn't matter. And second one, covariance of a constant and x. Okay? If C is a constant, covariance of a constant in a random variable, no matter x is what? How x assign its different values. The constant is always constant. So there is no linear association. There is no linear association between a constant and a random variable. Okay? So this is what? This is 0. Okay? And this is not very difficult to prove. Okay? Let's look at the proof. By shortcut formula, covariance of C and X is expected value of C times X minus EC times EX. Okay? And by property 2 of expected value, the constant we can pull out is C times expected value of X, and expected value of a constant is a constant itself. And this is just EX. So after cancellation, you can see this is 0, okay? So there is no linear association between a random variable and a constant, okay? Now the third one, Property 3. Covariance of XX. What's covariance of XX? As you can see, covariance XX is what? Expected value of X times X minus EX times EX. And this is EX squared minus EX, the whole thing squared. So this is equal to what? Variance of X. So covariance XX is just what? Variance of X, okay? Now property 4. Property 4. Well, why don't you think about this before we go any further? Let's take what? A 30 seconds break. Okay. Next one. Covariance of Cx and y, where C is a constant. Okay. This is just what? This is just equal to C times covariance xy. And to prove this is also quite straightforward. Okay, let's see. Covariance of Cx and y by the shortcut formula is expected value of Cx times y, and then subtract by expected value of Cx times expected value of y, okay? And this C is a constant, we can pull it out. So I can write this one as expected value of Exy, and subtract by expected value of C times X by property 2 of expected value. This C can be pulled out. So we can rewrite as expected, the C times expected value of X times expected value of Y. Okay? So C is a common constant. It's a common factor. We can take it out. Okay? That's expected value of XY minus EX times EY. And this gives what? C times covariance of XY. Okay? That is property 4. Let's look at property 5. Okay? Before we move to the property 5, let's take another 10 seconds break. Okay? Now, suppose given X, Y, W are random variables, then covariance, excuse me, covariance W and what? And X plus Y is equal to covariance X WX plus covariance WY. Okay? And to prove this is also quite straightforward. Okay? I'm going to give you the proof on the next page. Okay. We want to show covariance of W and X plus Y. Now, look at this. By shortcut formula, this is expected value of W times what? X plus Y. And then minus expected value of W times expected value of X plus Y. Okay? So this one gives expected value of W times X plus W times Y. And subtract by expected value of W times, this one can be written as EX plus what? Plus EY. Okay? And by property of expected value, property 3, I can write this one as expected value of WX plus expected value of WY. And then subtract by EW times EX. And this times this minus EW times EY. Okay? So let me regroup the terms. I put these two together. Okay? As you can see, expected value of WX minus EW times EX. This is just covariance what? WX. And these two terms, EWY minus EW times EY. This is just what? Covariance W and Y. Okay? So you can see this is what we want to prove. Okay? Think about this for 10 seconds as well. Okay, let's move to the next one. Okay, next property. Next property is what? Extended from what we see in what? In property 5. Okay. In property 5 says what? Property 5 says covariance W and X plus Y is equal to covariance WX plus what? Covariance WY. Okay? Now think about W now as Sn plus T. Next property, property 6. Covariance S plus T and X plus Y. By using property 5, we can get this is what? Just call this is what? Call this is W. We can get this is covariance what? W X plus Y plus covariance well, let's see, that's what I want to do here. Yeah, covariance WX plus covariance what? WY. But W is S plus T, so we apply to here. So it's covariance what? S plus T and X plus covariance S plus T and Y. Okay? So apply property 5 again. This is just covariance Sx plus covariance Tx plus covariance Sy plus covariance Ty. Okay? So let's summarize what is property 6. Property 6 actually is 10 from what we understand on property 5. Okay? Covariance S plus T and x plus y can be written as, first one, covariance Sx plus covariance Sy plus covariance Tx plus covariance Ty. As you compare these two, they are the same, okay? Now, next one, property 7, okay? Property 7. Covariance x plus y and x plus y. By using property 6, we can rewrite this as covariance xx. And the second term, covariance xy. And next term, covariance yx plus covariance what? Yy. Okay? Now, summarize from before. We know covariance xx is just what? Just variance of x. Okay? And covariance xy and covariance yx, they are the same. So it's 2 times covariance what? Xy. And plus covariance yy is what? Is variance y. Okay? And what do you know about covariance x plus y and x plus y? Remember, it's just what? This is just variance x plus y. So that's why before we always say what? We always say variance of x plus y is equal to variance x plus variance y. There's a condition need to be satisfied. What is the condition? Huh? X and y are what? Are independent. Because when x and y are independent, there is no association between x and y. This guarantees that there is no linear association between what? X and y. Okay? X and y are independent. That means no association between x and y. That is to say covariance what? That implies no association between x and y. That implies no linear association between x and y. No linear association between x and y, that is what we say covariance xy equal to what? 0. Okay? Okay? Now let's go over this quickly again. Okay? Variance of x plus y is equal to variance x plus variance y. That's we covered before. In order to have equality hold, we always say x and y need to be independent. Because when x and y are independent, this implies no association between x and y. Since there's no association between x and y, this further implies no linear association between x and y. Remember, covariance is used to measure the linear association. So when I say no association between x and y, it actually applies no linear association between x and y. So covariance xy must be what? Equal to 0. Think about this term is equal to 0. Then variance x plus y is equal to variance x plus variance y. But if x and y are not independent, then we have this what? Then we have this covariance term here. Okay? Now this is property 7. Okay? Let's take a short break for what? 20 seconds. Then continue to finish the topic. Okay, let's flip to the next page. Okay. Property A is actually extended from what we mentioned on property 7, okay? X and Y are independent. This implies what? This implies no associations between X and Y. And this definitely implies no linear association between X and Y. And no linear association between X and Y means what? Covariance XY equal to 0. Okay, so let's summarize this again. If I say X, well, X and Y are independent. This is my shorthand notation. X independent with Y. Okay, so X and Y are independent. This implies covariance XY equal to 0. However, the reverse direction is not true. Okay, but covariance x, y equal to 0 doesn't imply x and y are independent. Okay, let me give you a very a simple example. Okay, let me give you a very simple example. Look at the random variable x here. This is x, this is px. Okay, consider a random variable x. And x has only 3 possible values, -1, 0, and 1. Okay, x will be 0 with probability what? 2/4. And x equal to -1, that chance is 1/4. And x is equal to 1, the chance is what? 1/4. Okay, now we define y is equal to x squared. Okay, so define y equal to x squared. What does that mean? Well, that means there is a perfect quadratic association between what? X and Y. Huh? There is a perfect quadratic association between X and Y. Now, let's think about how about the linear association. How about the linear association between what? Between X and Y. Okay, that's what we want to discuss next. Okay. Now, given y is equal to x squared, so the PNF of y. Okay, only 2 possible values. Y can only be what? 0 or 1. When x is 0, x squared is still 0. So y equal to 0 come from what? X equal to 0. probability y equal to 0 is equal to probability x squared equal to what? 0. Remember y is x squared, right? But x squared equal to 0. The only chance is what? X equal to 0. And that chance is 2 over 4. Okay? Now, how about y equal to 1? Y equal to 1 is probability what? X squared equal to 1. X squared equal to 1 can come from two possible situations. First one, x is 1, or x is minus 1. So the probability is 1 over 4 plus 1 over 4. And this gives what? 2 over 4. So this is also 2 over 4. Can you see that? Okay. Now let's see what's the covariance of x and y. By the shortcut formula, it's expected value of xy minus ex times ey. Okay? Now, this is expected value of xy minus, what is ex? Look at here, what's ex? Can you see ex is 0? Minus 1 times 1 over 4. Well, ex is what? Ex is 0. And why ex is 0? Minus 1 times 1 over 4. Plus 0 times what? 2 over 4. Plus 1 times 1 over 4. This term cancels this term, so it's 0. Okay? So this is what? Ex is 0. So we don't need to find ey, right? So this is ex is what? 0. So all we need to find is just exy, right? How are we going to find exy? Okay? Let's stop here for what? For 20 seconds. Think about what I just said. Then we continue to what? I'm going to flip to the next page. Finish up this one, okay? Okay, let's move on. Okay, yeah. You want to take a look again if you want to. Yeah. Okay, can I move on? Let's move on. Next one we want to find. Next one we're going to find expected value of x and y. This is something we can use a Q table from your textbook, what? Page 106. Okay. Okay. You can use Q table which can be found on page 106 of your textbook. Okay. Now this is a way how we're going to control what? The Q table. X is equal to -1, x is equal to 0, x is equal to 1. Remember, x has only 3 possible values, right? -1, 0, and 1, okay? And how about y? Y can only be 0 or what? Or 1, okay? Can only be 0 or 1. And this is Q table. Value Q is equal to, in this case, x times y. Okay, x times y. So when x is -1, y is 0. What's x times y? That is just 0. Okay? And when x is -1, y is 1. X times y is what? Is -1. Okay? And when x is 0, y is 0. X times y is 0. Okay? And when x is 0, y is 1, that probability, well, that number, x times y, 0 times 1 is still 0. Okay? And y is 0, x is 1, x times y is still 0. And x is 1, y is 1, x times y is 1. Okay? So we can see what's expected value of x times y. Expected value of x and y come from these 4 parts. Can you see that? So that is 0 times what? Probability x times y equal to 0. And then plus, Q can be what? Possible value of Q, which is x times y, can only be what? Can only be -1, 0, and what? And 1. Okay, if we list the table like this, this is Q, this is probability of Q. Okay, and it can only be -1, 0, or 1. Okay, so what is the probability that Q equal to -1? Q equal to -1, that means what? That means x times y equal to what? -1. And look at this combination. The only chance you can get Q is -1 is from here. X is -1, y is 1. Okay? So this is probability that x equal to -1 and y equal to what? Y equal to 1. And that is just probability x equal to what? -1. Because y is equal to what? Since y is equal to x squared. When x is -1, x squared must be 1. So this is just x equal to -1. But what's x equal to -1? X equal to -1, the chance is 1 over 4. Okay? The chance is 1 over 4. So this chance is 1 over 4. This chance is 1 over 4. Okay? Now, next one, how about Q equal to 1? Q equal to 1 from Q table, you can see it can, the only chance you can get Q equal to 1 is x equal to 1 and y equal to 1. Okay? So this is x times y equal to 1. And the only chance you can see that happen is x equal to 1 and y equal to 1. And that's just what? That's just probability x equal to 1. Again, because y is equal to x squared, right? So x is 1, it's squared, y must be 1. Okay, so this is x equal to 1. But what is the chance x equal to 1? The chance x equal to 1, again, here is 1 over 4. So let's just copy it here. This is 1 over 4. Okay, so this is 1 over 4. And we know the probability should sum up to what? Sum up to 1. So this must be what? 2 over 4. With the P and F of Q, we are ready to find what? What's the expected value of x times y, okay? So it's 0 times pxy equal to 0. Huh? Plus what? Minus 1 times probability xy equal to minus 1. Plus, this is 1 times probability xy equal to 1. And 0 times everything, well, 0 times what? That change is 2 over 4. That is 0. Plus minus 1 times xy equal to minus 1. Xy equal to minus 1 is what? 1 over 4. Plus 1 times what? Xy equal to 1, that is 1 over 4. So these two cancel, which gives what? 0. So let's come back to see this. Covariance x, y equal to, by shortcut formula, expected value of x times y minus ex times ey. And we find ex is 0. And we find exy is 0. And ex is also 0. And ey is what? Ey is 1/2. But 0 times 1/2 still 0. So it's 0. So what do you learn? Look at here. Look at our example here. Y is equal to x squared. There is a perfect quadratic association between x and y. But how about the linear association between x and y? Remember, linear association between x and y, we use covariance. Now we find covariance x and y is 0. So you can see. Covariance x and y equal to 0 only implies no linear association between x and y. But you may see other association. For our example, x and y have what? A perfect quadratic association. So let's go over this again, okay? Covariance x and y only means no linear association. So covariance x and y equal to 0 doesn't mean what? X and y are independent. But when I say x and y are independent, it implies no association. Therefore, also implies no linear association. So if I say x and y are independent, that implies covariance x, y must be equal to 0. No linear association. But covariance x and y equal to 0 doesn't imply x and y are independent. Is that clear? This is very important concept. Okay, let's take a short break for what? 20 seconds here. Okay, and then I'm going to cover the last property today. Okay, let's proceed to what? Let's proceed to the last property, okay? Let's proceed to the last property. Okay, let's proceed to the last property. Property 9. This is called correlation coefficient. This is defined to be covariance x, y, and divided by standard deviation of x times standard deviation of y. So this is correlation coefficient. What's a correlation coefficient? It's the scale version of what? Covariance x and y. Okay? Why we want to scale it? Sometimes you find covariance x and y is 5,000. And covariance ST may be what? 2.5. Huh? Very difficult to what? Compare them. So if you come up with a scale version of covariance, after you scale it, okay, kind of standardize it, the important property about correlation coefficient is that this number has to be what? Between -1 and 1, okay? This number has to be between 1 and -1, okay? So it's just like a probability between 0 and 1. Easier for us to make the comparison with two what? Such quantities, okay? This one looks strange, right? But if you convert the number only between 1 and -1, it will be easier, okay? It will be easier. So this is just like a covariance x and y. Correlation coefficient is also used to describe the direction and strength of linear association between two quantitative variables. x and y, okay? But this is a scale version of correlation coefficient, okay? When rho x and y greater than 0, that means there is a positive association between x and y. Positive association means what? Large x are more related to large y's. Okay? Now, rho x and y less than 0, that means negative association. Negative association means large x are more related to what? Huh? Small y's. Okay? And rho x y equal to 0. Okay? Remember, you can never say what? No association. Remember, this is wrong. Because this only measure what? Linear association. So you cannot say that. Okay? What you can say is what? No linear association between x and y. Okay? I think that's all for my lecture today. Okay? I still need to talk to you guys if you're still online. I'm going to start recording. Okay?